Okay, thank you, Trisa. This is Stephen, and if you have been previous MVC platform, you know I will take this time to talk about one of the CTU patent or pending patent technology. So today I will talk about one of the technologies regarding to make the control of the sensing material growth, the crystal growth. So before going into the technology detail, let's take a look at the marketing the situation. This chart can show that the total gas sensor detector or analyze market globally from 2018 to 2025, it can reach a annual growth to about 4%, and by 2025, the market in the globally can reach 4.7 billion US dollars. But you can see this is a big market, but it's also a difficult market because you can see some of the comment is the size of this sensor have to be compact and the lightweight, and also it's portable, definitely. And the lifetime has to be long, and also it can operate in a harsh environment. Moreover, it had to be accurate and the right range of gas detection, and also a high adaptability, but it's inventable that all the sensors have to be low cost. So this is a very harsh market. So regarding the technology, today I talk about is regarding a synthesis method, okay, to control the transition metal. Because as you know, most of the sensing material is made up of the transition metal. What is the transition metal? For example, nickel, cobalt, tungsten, or zinc. These are the transition metals in the periodic table. And this transition metal, most of them is used for sensing, used for gas sensing material. For example, when the gas you want to detect, you reach this material, the electronic property or so-called, let's say the resistance or the capacity will be changed. Okay, so based on this kind of property, you can detect, oh, there's a gas rich this material. So it's performed as a sensor. But you can find that the crystal size or the shape of the crystal, this kind of transition metal, will be changed the property of this kind, will change the electronic property of this sensing material. And this chart, you can see that this method we try to control the solvent polarity. Okay, for example, some solvent, let's say water is a very polarity solvent. But we try to control some other solvent. Let's say we add a longer carbon change alcohol, okay, to dissolve this transition metal, and then growth this transition metal come out in the different shape. For example, in the first one, you can see the green one. We try to suppress the growth. We try to promote the growth on let's say the dimension, the C dimension. Okay, eventually it will go in the rod shape. Then the middle one in the blue color, okay, let's say we try to suspect the growth on the dimension of C. It come out eventually, it will become a cross shape. And then the last one, if we suppress the dimension of C, eventually it will be a flower shape. Okay, so it comes from a different kind of shape. But what is the property of this kind of shape? In our laboratory, we try to use the zinc oxide. Okay, this is the right-hand side, you can see those transmission electron microscope. It shows the shape. We use the zinc oxide as one of the example to detect ammonium gas. You can find that, okay, the green one, the S1, okay, the response time is much faster than the other two, S2 and S3. You can see the gas in and the gas out time is around 10 seconds or 36 seconds, okay. But the other two is take longer. And also the response in terms of the resistivity, okay, is much great different. In the bottom, you can see the chart D. You can see the green one is the S1 shape. Okay, the response time is much, let's say, is almost 10 times to other shape of the crystal. And also compared to the detecting gas, okay, let's say ammonium, the S1 shape is more sensitive. So it's very interesting, the different shape of the crystal, it comes out with different electronic property. So it's enhanced the sensor property or the performance. So this patent technology is, we can precisely control the growth of the crystal shape in this transition metal. So all in all, this is the advantage of this technology. And it can improve the sensitivity and response time for the gas sensor. And also, this method is not complicated, and also the cost is affordable. And definitely for the application is used for the gas sensing material, but if some of the application use the transition metal, we can look into how to control the crystal growth. Then this technology it should be implementable. So that's all my presentation. Again, if you want to find more CTU patent, please go to our KTO website. You can find more CTU patent technology.
Thanks, Stephen. Now, I just want to have a follow-on question here. It's important to share what you have, and based on what you have shared, it's a methodology of creating crystals that you could actually use as a sensor, and specifically gas sensing. Now then, if I want to put it in the context of our daily life, what's the big deal about being able to sense gas, right? Now here's the thing. It's not meant to be a crude joke, but all kinds of gases that we are enveloped in, right? Now, if people are aware of what is volatile organic compounds, most people may not know what is a VOC, volatile organic compounds. These could be things that are in the very space that we are now sitting in. These could be toxic gases. So the question I have is, because these crystals, the patent itself is actually a method of making these crystals who are able to be used in a sensor. Is it a case that we can tune these crystals for sensing different types of gases?
Exactly. So different type of gas, they use different kind of transition metal for the detection. But definitely, the example I mentioned is use zinc oxide, but to detect ammonium gas. But if let's say you test another VOC gas, you may need to use another kind of transition metal. But the shape of this crystal growth will totally be different. Okay, it may be better in a flower shape. Okay, so you have to test it. Okay, there's no genetic way. Okay, this should be better for all the gases. No, definitely no.
So you can create a fingerprint.
Yep.
That means you could detect different types of gas. If you look at it from the perspective of technology development, right? If let's say I am a company that is into the business of doing live events, how do you correlate live events with a gas sensor? Think about it this way. If you have thousands of people gathering, there is actually quite a bit of a risk there. If there are gases that are being released amongst the thousands of people who gathered, and for whatever reason they are volatile, they can explode. You have thousands of people being caught in an explosion, like at a party or a New Year celebration. That could be very dangerous. So if I'm an events organizer, even then I may hire people who are specialists, who has this ability to disseminate those sensors in the venue that I'm having this event. That's one business model. So the making of such sensors or being a supplier of such sensors becomes important. And it's actually a specialized way of doing things. This is not limited to what I've just described at an event. It could be transportation, shipping companies, shipping vegetables and fruits. You'd be surprised that they need sensors to regulate the kind of gas that fruits give out. Fruits, they are actually not as what we think, just sitting there. They actually, the moment that you get them from the farm, they start disintegrating. They will be giving out gases. And if you have tons of them in a ship, a tanker, they are giving out a lot of gases. So these are the kind of technologies whereby people may not notice, but actually they are very useful and very important. There's opportunity there. So I think what's important is what we're trying to share here is that there's research that's done within CityU whereby it can actually give people opportunities that they never think about. While we sit inside KTO, and you'll be wondering, why don't the people in KTO, they talk so much, why don't they do it themselves? The problem is, we can't become entrepreneurs. We are stewards of the university's IP. But what we're trying to tell you is that there's a lot of opportunity that sits within CityU, and it's up to you to actually uncover it because we make it available to you. Today's session, I think we're kind of running into the end of until 5:30, right? So if there are no more questions, I'm seeing that, I'm just doing a last check. There are no more questions, then I think we'll call today's session a close. And anybody who has follow-up questions, you are welcome to come forward and ping us at the CityU KTO. Thank you very much for your time. Have a nice weekend ahead. Tomorrow is already Friday. Bye, everyone.